Hello everyone, myself Akriti Saxena. I wish you all are in good health. Today I am going to discuss my work mitigating misinformation in online social network with top K debunkers and evolving user opinions. This work has been performed at National University of Singapore. Co-authors Professor Vinishu, Professor Mongli, Hai Leong, Glennet and Lunan. First, we will discuss the introduction where, where we will build the basics of the problem. Next, we will discuss the proposed user opinion model, followed by a fake news mitigation method that is built on the proposed user opinion model. Then we will discuss experimental results and conclusion. Online social networks like Twitter, Facebook, Weibo are popular platforms where users interact and share information. Recently, online social networks have been used extensively to spread fake news, misinformation, or extreme ideologies. As you all know, we share information on these online social networking platforms in the form of microblogs, or you call them tweets or posts. It is very easy to share information there, and it just takes few seconds to reach the information to many users. The severe consequences of misinformation propagation on major events, including the US and Jakarta elections, are well known. The further details are explained in the paper. After these events, researchers have focused on detecting or mitigating fake news. Main directions in this area are detecting misinformation, where we have a microblog and we identify whether this is a useful information or misinformation or fake news based on the content of the microblog and user profile or other metadata. Then another direction focuses on developing systems to automatically check the credibility of information and verifying the social media content. Uh, Next, another direction is mitigating misinformation, where we try to minimize the influence of misinformation or fake news on online social network. In this work, we are going to focus on this direction. So there are mainly two kinds of methods to mitigate misinformation. The first one is influence blocking. In this method, we identify and block top keynotes such that the spread of the misinformation is minimized. So we assume that the selected keynotes will not spread the misinformation or information further in the network. That is not a realistic assumption. So another direction of the research for mitigating misinformation is truth campaigning based methods, where we choose most effective notes to propagate the counter message to minimize the influence of misinformation. So in this work, we are going to focus on truth campaigning based methods, where we have a given set of debunkers and we will choose top keynotes to spread the counter message so that the influence of misinformation is minimized. I'll discuss further details later in the presentation. So first we'll see how the opinion is propagated in the network, and we propose a user opinion model for minimizing misinformation. Here I'll discuss terminologies. So GV is the given graph. M is a set of seed users who spread the misinformation, and D is the set of candidate debunkers. M and T are the persistent users whose beliefs never change at all, or you can call them stubborn users. Then rest of the nodes belong to set R, whose beliefs depend on the states of their neighbors in the network. So initially, the state of each user is defined as the state of the users belonging to set M is -1 as they spread the misinformation. The state of the users belonging to the set of candidate debunkers is 1 and the state of regular users is 0. The PUV is the influence probability of node U to node V. In the proposed model, each user has bias towards a misinformation and counter message. This is denoted by PVM and BVD respectively. And alpha is the deadline of the effectiveness of the misinformation. As in many real world scenarios, a rumor or misinformation has a deadline and or a timeline, and after that time the misinformation or the rumor is not harmful for the given system. So we have considered this parameter. Now we will see how opinions are propagated. So depending on the belief of uh, you will propagate the counter message or misinformation and attempt to influence its neighbor V with the given influence probability. So the probability that the node V will believe in the counter news is computed using the given formula. So for a node V, we will take its neighbors who believe in the counter news and will see their impact on the node V and will compute its probability in believing the counter news. Similarly, we will compute the probability that we will believe in the misinformation at time t. So this is computed as using the given formula. Then now we have both the probabilities. The first probability that node V will believe in the counter news. Second probability that node V will believe in the misinformation. Using these probabilities, we will compute the state of node V at given time t. And in this formula, epsilon is a small value to depict the user's resistance to change the state. This is a detailed algorithm where first we initialize the state of the users belonging to different set as a state is equals to -1 for the node belonging to M. The state is 1 for the node belonging to debunkers and rest of the nodes have state 0. Then for each node we compute the state of the node based on its neighbor and we repeat this method for the given deadline alpha. And in the end we have the final state of all the users. Now we validate the proposed method on the tutor dataset that was collected by Cohen et al. We extract the data of 5 events. The first event is George Tiller event. It has tweets on the news that Dr. George Tiller shot at his church. Next event contains tweet on Iran protest video. Then the next event is the collection of the tweets on the reviews of a pocket PC, Palm Pre. Next, we have tweets on the information and reviews about a mobile device, PSP Go. And the last event, swine pork, where we have tweets about a rumor that swine flu can be propagated by pork. So, to validate the model, we compute bias of the users. First, we assign a polarity to each tweet and deem a tweet as positive if its polarity is greater than 0, negative if its polarity is less than 0, and neutral otherwise. Then the user state is computed as a user has a ground truth state of 1 if he has posted more positive tweets than negative tweets and vice versa. A user has a ground truth state of 0 if the user has posted only neutral tweets or equal number of positive and negative tweets. The considered dataset is sparse, so we have used this method to decide the state of a user. Next, we compute the bias values. The bias of a user V towards misinformation is given by the ratio of negative tweets to the total number of tweets posted by V. Similarly, we will compute the bias of the node V towards counter message. So now we have the state of the user and bias value. Next, we compute the influence probability of an edge, and the influence probability of an edge is the sum of the minimum of the number of tweets posted by U and V in each category to the total number of tweets posted by V. So if we have a node U and node V, and we want to compute the influence probability of node U and V, we will see how many similar kind of tweets are posted by both of these nodes, and we'll use this information to compute the influence probability. To compute the state, the tweets are sorted by the time and use the first half to estimate the initial state of the user, and use the opinion model in MIST to predict the final states of the user. For the ground truth, the final state is computed by considering the complete data. We compare the proposed method with two other models. The first one is opinion formation model. In opinion formation model, a node's opinion is determined by the average weighted sum of its neighbor's opinion. The next one is independent cascade model. In independent cascade model, a node V can be influenced by its neighbor with the probability PUV if it has not been activated. Once activated, the node will not change its state. These are the results. As you can see, the proposed method outperforms the two models for all the events, and for the last swinepox event, the performance is the same as for the opinion formation model. Next, we will study how we can mitigate misinformation on online social network when the misinformation and counter messages are propagated using the proposed model. This is the problem definition. For a given graph G, a deadline alpha, set of seed users M who spread the misinformation, and a candidate set of debunker D, we aim to find a subset of D called D star of given size K. K can be considered as a buzzer such that the number of saved nodes is maximized. A node is called saved node if the node believes in the counter message by the end of the deadline when misinformation and counter message is propagated. Otherwise, the node would have believed in the misinformation. So, for the given set of users M who spread misinformation, we first compute the number of saved nodes for each debunker in D, and then we select top K debunkers who saves the maximum number of nodes. And then in the experiment, we will see how this method works. Other details are mentioned in the paper. So, we have studied this method on two data sets, Facebook and Twitter, having the network diameter 18 and 7. So these are the experiment setup details. The influence probability of each edge is given by 1 by n degree. Then we compute the bias values. So for computing the bias value, we assume that X% of the nodes are the stubborn nodes who believe in the misinformation. It means they have higher bias value for the misinformation, and we randomly assign a real value between 0.7 to 1 as the bias for these X% of the nodes. And for these nodes, the bias for the counter message is 1 minus the assigned bias value. Then we iteratively compute the bias of the remaining nodes in the network towards misinformation as the weighted average of their parents' biases based on their similarities using the given formula, and we repeat it till the deadline alpha. In the experiment, we have taken x equals to 10 and 24 Facebook and Twitter, as the Facebook is a smaller subgraph than the Twitter subgraph. The size of the candidate set of debunker D is 50. and we evaluate the performance of all methods based on the percentage of saved nodes. And as I explained earlier, a node is a safe node if by the end of the deadline the node believed in the counter message, otherwise it would have believed uh, in the misinformation. And each set of experiment is repeated 30 times and we record the average percentage of nodes saved. We compare our methods of finding top k debunker nodes with the following node selection method. First, we select k nodes randomly. Then, highest out degree, we select top k nodes with highest out degree. In highest weighted out degree, uh, this method selects the top k nodes with highest out degree weighted by the influence probability. And the last one is minimum distance. This method selects the top k nodes in D which are closest to the rumor starters. The closeness of a node U to M is computed by using the distance of node U with each node belonging to the set M. Here we can see as we vary the number of truth campaigners from 2 to 10, the percentage of saved nodes increases and the proposed method performs better than the other heuristic methods. Similar results are observed on Twitter network. We also compare our method with two state-of-the-art methods. The first method is temporal influence blocking. Temporal influence blocking method first identifies the set of nodes that can be reached by rumor starters before the deadline. Then TIB generates weighted reverse reachable trees to estimate the number of reachable nodes from the nodes belonging to debunker set, and then we select the top k nodes that is best able to block the rumor before the deadline. Another used method is targeted misinformation blocking method. This method computes the influence reduction of a node V. So the influence reduction is computed as the difference of the number of nodes influenced by rumor starter in the graph G with the presence and absence of the node V. And we select the top k nodes with the highest influence reduction as debunkers. Here we see the results as we vary the number of truth campaigners. We can see the proposed method outperforms both the state-of-the-art methods, and similar results are observed on Twitter network. Next, we study the method by varying different parameters. So here we vary the number of rumor starters and see how the performance varies. So as we increase the number of rumor starters, the performance decreases, but the proposed method performs better than the other methods. Similar results are observed on Twitter network. Then we vary the deadline and see and observe that the proposed method is outperforming other method when we vary the deadline on both the network. As I mentioned earlier, in the given network, we take the influence probability as 1 by n degree, but to generalize the results, we vary the influence probability and see whether in other scenarios how the proposed method performs as compared to other heuristic, and we can see that the results are better than other methods on both the networks. Then finally, we do the robustness experiments. We examine whether the debunkers found remain robust to counter the misinformation even when the initial influence probabilities and user bias estimates are noisy. For this, we first find the top key debunkers in the network which has these initial estimates. We then inject noise to the network by adding some random number to the influence probability of edges and bias values of users, which is sampled uniformly from a range minus eta to eta, and eta is from 0.005 to 0.025. So mainly we have a network. We have influence probability and bias values. We find a set of debunkers. Then we inject noise in the network and we see the already identified set of debunkers, whether it will perform better on the new network or not. So here we can see the percentage of nodes saved uh, in the case of MIST are more than the other methods for the given noise level, and similar results are observed for Twitter network. And these experiments are where we study the robustness for user bias values. And on both Facebook and Twitter, we observe that the MIST can handle the introduced noise. So in this presentation, we proposed a user opinion evolution model. We discussed it. Then we discussed a fake news mitigation method to identify top influential users from a given set of debunkers to maximize the number of users who have been exposed to misinformation but choose to believe the counter message by the given deadline. And we compared the proposed method with other heuristic methods and state-of-the-art methods. The proposed work can be extended further to propose a friend recommendation method so that the negative influence is minimized faster in a social network. In this presentation, I have tried my best to explain the things in a simpler way. Still, if you have any query, you can ask me or you can always write me. Thank you.